Okay, here on a service call on a train rooftop package unit, and we've got a bad transformer. So I replaced the transformer, but I also noticed that somebody has removed the fuse. There's no fuse protection on this transformer, so I've kind of added one with what I had off the truck until I can diagnose further. Well, upon powering it up, I'm blowing fuses, I am still got a low voltage short. So now it's time to start isolating. So the first thing that I'm going to start doing is pulling plugs off of major components like boards, and eventually you're going to stop blowing those fuses. So that I don't go through a bunch of fuses, you can either use one of those clicks-on circuit breakers. Those aren't always reliable. Me personally, I put my amp clamp around the red wire or whatever 24 volt hot wire, and I monitor that, and anything over about amp or two, I'm going to kill the power, because that means I have a short. And that's actually a quicker way of determining a short than waiting on a fuse or a circuit breaker to finally blow and risk blowing a brand new transformer. So I unplug all the plugs off this board and leave just the one harness that actually powers it from the transformer. When I threw power on there, within a few seconds, I started pulling 10 amps. So I quickly turn off the disconnect before I blow something up. Now it's time to determine which one of those wires is going to a component that's actually shorted. This is called the isolation method, and it's pretty much the best way of determining a low voltage short. That's usually very difficult for technicians to find. Essentially, you're removing things from the equation until you figure out what is and what is not blowing that fuse. So the next thing I want to know is what is on that wiring harness, because that seems to be the problem. When it and only it is hooked up, I'm still blowing fuses. So this is J1, that wiring harness that I left on the board. It starts over here, you've got your power coming in, but then it continues right here. If you start looking at some of the components that it feeds a high pressure switch circuit. It also feeds this component right here, F, and that is your indoor fan contactor. And I'm going to tell you, more likely than not, it is contactors and relays that cause low voltage shorts besides skint wires. So now we're going to isolate the contactor, pull the wire off of it, and see if we still blow a fuse. Okay, so I've powered the unit up after removing the coil wire from that fan contactor, and we've been powered up for about a minute, and this is what we're getting: 0.5 amps, which is pretty normal for control voltage. Of course, nothing's running yet, but I never got this far until I pulled that wire. So that contactor, I suspect, is shorted to ground, and we're going to verify that with an ohm meter next. All right, we are ohming out our contactor coil, and as you can see, we have 0.1 ohms, which is a dead short across that coil. So that is pretty much the cause of our low voltage issue. It's not necessarily a low voltage short to ground, even though the common is grounded here at the transformer, so it essentially is, but it is a hot to common short in this case. That's also a hot to ground short. So we're gonna replace this contactor, but before we do, just for kicks and giggles, I want to ohm out what a contactor coil typically should ohm out as, so I can use that as a reference next time. Alright, so we're ohming out our new contactor coil just so I can kind of put in the back of my mind what I would expect to see ohming out a coil. And as you can see, we're ohming out right at 10 ohms. So kind of store that in the back of your mind if you're ever suspecting that a contactor is starting to go bad. It might be chattering, it might be blowing fuses every now and then. Now obviously, not every contactor is going to ohm out exactly 10 ohms. A larger contactor is going to have more of a coil on it, so it needs a bigger magnet to pull those contacts in, so it's probably going to ohm out more. But this is your typical, 40 full load amp contactor that you would see in light commercial, residential. That's pretty standard. I mean, if you're ohming out a contactor and it's ohming out at 100 ohms, or it's ohming out at 0.2 ohms, then you know that's probably way off. But somewhere around 10 ohms seems to be the normal thing that you would read.